Previously, we learned how to use the Pythagorean identity to find the values of cosine and sine at points in the first quadrant of the unit circle. Now we'll learn how to extend this technique to other quadrants of the unit circle. Here's another example which is similar to the previous example. We're looking for sine theta again, and we've got our value for x, but this time we are in the third quadrant. And our approach is still going to be exactly the same as before. We're going to go ahead and find what cos theta is by using this x to our advantage. So we'll label this point as cos theta, comma, sine theta. And that shows us that cos theta is just negative 3/5. Cos theta is just the given x value. So we can substitute it into our Pythagorean identity and solve for sine. So let's do that. So cos squared becomes negative 3/5 squared. And we still have plus sine squared equals 1. Negative 3/5 squared, that's just 9 over 25. So 9 over 25 plus sine squared theta is equal to 1. And then subtracting 9/25, we get that sine squared theta is equal to 25 over 25 minus 9 over 25, which leaves just 16 over 25. And to get rid of that square, the square, we just take the square root, and we need to determine, is sine theta going to be positive or negative root? And to decide whether it's positive or negative, again we have to draw the Caste diagram. So cosine is positive in this quadrant. All the trig functions are positive in this quadrant. Sine only is positive in this quadrant. And tangent only is positive in this quadrant. So since in this quadrant, tangent is the only trig function that's positive, that tells us that sine needs to be negative. So we're going to take the negative root. So let's say sine is negative in quadrant 3. So we take the negative root, so we'll put a negative in front of it, and we'll evaluate the root. Root 16 is just 4, and root 25 is just 5. So sine theta is negative 4/5. Our last example is going to be the most challenging because it uses everything that we've learned so far. So we want to find a value of tangent theta, not sine theta, not cos theta, but tangent theta this time, at the point in the fourth quadrant of the unit circle where x is 0.8. So we're going to start off the same way as we usually do. We're going to put the point here, put our x here, label our x and our point. We've got the point 0.8y, and we know from the very beginning that this point is just cos theta, comma, sine theta. And we know how to find cosine theta and sine theta from previous exercises, but how are we going to find tangent theta? Well, remember that tangent theta can be written in terms of sine theta and cosine theta. Tangent theta is just sine theta divided by cosine theta. So if we can find sine theta and cosine theta, then we can compute tangent theta by just dividing. Okay, so let's do this. Let's find cosine theta and sine theta like we have in the previous examples. We know from our diagram here that cos theta is just 0.8. That's the very first thing we learned. Cos theta is 0.8. So we'll go ahead and plug this in. So this is equal to, we'll sub in 0.8 for cos theta. And then how about sine theta? Well, that involves the use of the Pythagorean identity. We're going to have to solve for it. So cos squared theta plus sine squared theta equals 1. And we know that cos squared theta is 0.8, so we can plug that in. 0.8 squared plus sine squared theta equals 1. And we can compute 0.8 squared is just 0.64. So 0.64 plus sine squared theta equals 1. And we can subtract that to the other side to get sine squared theta alone. So sine squared theta is just equal to 1 minus 0.64, which is just 0.36. And we'll go ahead and take the square root to cancel out that squared on the sine theta. But we have to ask, do we want the positive or the negative root here? So we draw our Caste diagram. Caste diagram tells us that in this quadrant, cosine is the only positive one. In this quadrant, all trig functions are positive. This quadrant, sine is positive, and in this quadrant, tangent is positive. We're in the first, we're in the C quadrant here, which tells us that cosine is the only one that's positive. So that means sine is negative, and we want the negative root here. So sine is negative in quadrant, this is quadrant 4. Okay, so that means sine theta is the negative root of 0.36. And we can compute that root. That comes out really nice. It's just 0.6. So sine theta is negative 0.6. And we can go ahead and plug that in to our tangent computation up there. Negative 0.6. And we are good to go and compute. So we'll just multiply the top and bottom by 10, and we get, this is negative 6 over 8, which can be simplified to negative 3 over 4 if we divide by 2 on top and bottom. So tangent is just negative 3 over 4. There we go. In the future, we'll see more uses of this Pythagorean identity in trig form, and we'll also do some more practice computing trig ratios in all 4 quadrants.